Good morning, fourth graders. Today we are on page 163, and our objective for today is, today I will generate a number pattern following a given rule. Okay, so let's look at that one more time. So today I will generate. Generate's just another word for create. So today I will create a number pattern following a given rule. So we actually did patterns in the last unit in lessons 8, 9, and 10. So we've already had 3 lessons on patterns. What you're going to notice today is you'll see a lot of the same vocabulary, but because we're in the multiplication unit, this time our patterns are going to involve multiplication. So let's look at our vocabulary. Okay, our first word is what a pattern is. A sequence of shapes or numbers that follow a rule. Because we're doing multiplication, ours are going to be on numbers, not shapes. A growing pattern is a pattern that increases with each term. Now, since our patterns are going to involve multiplication, and multiplication usually increases your number, our patterns are going to all be considered growing patterns. Sequence is a set of numbers or shapes that are in order. Term, we had this same vocabulary word in lessons 1, 8, 1, 9, and 1, 10. Term is the ordinal position of an object or number in the pattern. So here's our pattern, 2, 4, 8, 16, and 32. And this is the first term because it's the first one. This is the 5th term. That would be our 2nd term, our 3rd term, and our 4th term. Term is just what spot is it? What number is it? Okay? And here's the example. We'll talk about that in a little bit. A rule is a statement that explains the sequence of the pattern. And then a feature, if you remember from the other lessons, is just a special quality or characteristic. Something that I can say about all those numbers. Now, there's many different features you could say. I think for this one, the most obvious feature is that all my numbers are even. All numbers in the pattern are even. Okay, let's look at our steps today. They're really good and we're going to be following them pretty closely. Okay, our first step says we're going to underline the starting number. So I'm going to underline the starting number. Then it says I'm going to circle the rule. I'm going to box the number of terms needed. I'm going to draw lines to represent each term so I know how many spots to fill in. And then I'm going to write your starting value on the first line, and then I'm just going to continue. It says if the rule has more than one step, follow the steps in order. You'll see this on my second example. We're going to complete the pattern and then identify a feature on the pattern. Okay, so I'm going to jump in and get started. As I'm working, ladies and gentlemen, why don't you follow my steps and see what I'm doing. Okay, here is my first problem. Okay, here is my rule. It says, starting with 1, create a pattern that grows by multiplying the previous number by 3. Stop when you have 7 terms. Okay, so let's look at my steps. My steps say I'm going to underline the starting number. So it says starting with 1. What's my rule? Create a pattern that grows by multiplying the previous number by 3. That is my rule. So I'm going to be having my pattern grow by 3 each time. Okay, it says box in the number of terms needed. Stop when you have 7 terms. Okay, so I'm going to start with number 1, but I'm going to have 1, 2, 3, 4, 5, 6, 7 terms. So 1 term, this is going to be my first term, 2nd, 3rd, 4th, 5th, 6th, and 7th. and they said I have to go till I have 7. Okay, they said my first term is going to be 1. Okay, so now my rule is grows by multiplying the previous number by 3. So my rule is times 3 each time. So 1 times 3 is 3. So my second term is 3. Okay, what's my rule? Times 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3. Okay, now I've hit a spot that I can't do in my head anymore. So I'm going to need to do some side work. So 27 times 3, I could set up an area model for that. And I could say 3 times 20 is 60. And 3 times 7 is 21. So 60 plus 21 is 81. Okay, so my fifth term was 81. Now I can multiply by 3 again. And I can't do 81 times 3 in my head, so I'll have to set up another area model. And I get 80 plus 1 times 3. Okay, so 3 times 80 is 240. And 3 times 1 is 3. So 240 plus 3 is 243. Okay, these numbers are getting really, really large. And I have to multiply by 3 again because I have to get all the way here. Well, I definitely can't do 240 times 3 in my head. That's definitely not going to work. So I probably would use another area model for that. I'm going to move up here so I have some room. So if I did my area model, they definitely did not leave me enough room. 200 plus 40 plus 3. Okay, so 3 times 200 is 600. 3 times 40 is 120. And 3 times 3 is 9. Okay, so what do we get? We have 600 plus 120 plus 9. I'm getting 729. Okay, so I did exactly what they asked. I followed the rule for the pattern. I started with 1 and I stopped at my 7th term. They also want me to say a feature. So something that I noticed really quickly on this one is every single term is odd. So all my terms are odd would probably be the easiest feature to choose. Okay, let's look at my next one. It says, create a pattern that starts at 1 and grows by multiplying the previous number by 4 and then subtracts 1. Stop when you have 6 terms. Okay, so let's look back. It says I'm going to create a pattern that starts at 1. My rule is trickier this time. It says grows by multiplying the previous number by 4 and then subtracts 1. It's a 2-step rule. So I have to multiply by 4, then subtract by 1. And it says I need to have at least 6, or not at least, I need to have exactly 6 terms. Okay, so I need 1, 2, 3, 4, 5, 6 terms. And my first number is going to be 1, and then I get to stop at my 6th term. So I can get started following my rule. So my rule is 1 times 4 and then minus 1. So 1 times 4 is 4, minus 1 is 3. Okay. So this rule is going to be times 4 minus 1. So 3 times 4 is 12. 12 minus 1 is 11. Okay, my same rule. 11 times 4 is 44, minus 1 is 43. Okay, 43 times 4. I cannot do that in my head, so I'm going to come down here and set up an area model for 43 times 4. So 4 times 4 is 16, so it's 160. 4 times 3 is 12. So I have 160 plus 12 equals 172. So 43 times 4 is 172, but they want me to take away 1, so it's 171. Okay, and then my rule is times 4 minus 1. So again, I can't do this in my head, so I'm going to use another area model. And I have 100 plus 70 plus 1. Okay, so 4 times 100 is 400. 4 times 70, well, 4 times 7 is 28, so it's 280. And 4 times 1 is 4. Okay, so let's add up our partial products. 400, 280, 4. And I am getting 684, but I have to also subtract 1. So it would be 683. So our terms are 1, 3, 11, 43, 171, and 683. Okay, so ladies and gentlemen, let's try some of these together. Notice how it was really crowded with my side work, which is all this extra work that was required. You can always use scratch paper if you need to. Okay, we are on page 164. If you can turn to page 164 and join me. Okay, our question says, create a pattern that starts at 4 and grows by multiplying the previous number by 2. Stop when you have 7 terms. Okay, so it says they want us, it says create a pattern that starts at 4. Our rule is and grows by multiplying the previous number by 2. And stop when you have 7 terms. Okay, so we need 7 lines. 1, 2, 3, 4, 5, 6, 7. They want us to go all the way to the 7th term. Okay, they also told us our first number is going to be 4 because it says starts at 4. Okay, and then it says multiplying the previous number by 2. So our rule is each time we're going to times 2. Okay, so now we can get started. 4 times 2 is 8. 8 times 2 is 16. 16 times 2, that's not a basic fact. So you might need to work that out using an area model. You could also use the distributive property. Okay, so I'm going to do the area model. And I'm going to say 2 times 10 plus 6. 2 times 10 is 20. And 2 times 6 is 12. So I get 20 plus 12 equals 32. Okay, now we have 32 times 2. 32 times 2. You might, for this one, I would maybe even use that, if you remember back the distributive property, that would be a good one for this one because I know some of these. So 32 times 2, I could say 2 times 32, which I could say is 2 times 30 plus 2. Well, 2 times 30 plus 2 times 2. So I could say 2 times 30 is 60 plus, because remember in the distributive property I passed that out, so 2 times 30 plus 2 times 2. So I'm getting 60 plus 4 is 64. I like the distributive property sometimes for smaller numbers. And I could have even said, I could just see it's 2 times 30, which is 60, and 2 times 2. Okay, now we have 64 times 2. I might go back to the area model for this one. So I'm going to set it up. Two times 60. Well, 2 times 6 is 12, so it's 120. And 2 times 4 is 8. So we have 120 plus 8 equals 128. Whew, we're getting there. Okay, so our last one is 128 times 2. And again, we don't have room for that. So I'm going to come up here and use this space to try and solve that. So I have 100 plus 20 plus 8. So we have 2 times 100 is 200. 2 times 20 is 40. And 2 times 8 is 16. So we have 200 plus 40 plus 16 equals 256. And we're finally at our 7th term, so we get to stop. Okay, so what feature do you notice? What's something when you just look at all these numbers do you notice? 4, 8, 16, 32, 64, 128, and 256. I probably noticed right away that they're all even. So that could be a feature, that all of the terms in the pattern are even. Okay, let's look at our last one together. It says, starting with 2, create a pattern that grows by multiplying the previous number by 3 and then adds 1. Stop when you have 6 terms. Okay, so it says starting with 2, that's our starting number. Create a pattern that grows by multiplying the previous number by 3 and then adds 1. So again, we have a 2-step rule. Stop when you have 6 terms. Okay, so let's make our lines. 1, 2, 3, 4, 5, 6. Here's our 6th term we have to go to. Okay, so we can get started. It says we're going to start with 2. And our rule is we're going to multiply by 3 and then add 1. So we have 2 times 3 is 6. 6 plus 1 is 7. Okay, so let's set up our next rule. Multiply by 3 and add 1. So 7 times 3 is 21. 21 plus 1 is 22. Okay. So our rule, 22 times 3. This would maybe be a good one for the distributive property. I could even do this part in my head because I could say 2 20s is 60 and, or I'm sorry, 3 20s is 60. So 3 times 20 is 60 and 3 times 2 is 6. That's that neat thing about that distributive property. So 3 times 20 would be 60 and 3 times 2 is 6, so it's 66. So I know my answer is 66, but if I add one more, I get 67. That distributive property is really nice on some of them. This is probably one I wouldn't do the distributive property for because it's a little trickier to do 3 60s and 3 7s. So this one I think I'll do the area model for. So let's set it up. We have 60 plus 7 times 3. So 3 times 60, well 3 times 6 is 18, so it's 180. 3 times 7 is 21. Okay, so we get 180 plus 21 equals 201. Okay, but our rule also says we have to add 1. So it's 201 plus 1, which gives us 202. Okay, we're getting there. Our final one, 202 times 3. Okay, so let's set up our area model. 200, we don't have anything in the tens place, but we have a 2. So 3 times 200 is 600. 3 times 2 is 6. So I get 600 plus 6 equals 606. Plus 1 would be 607. Okay, so let's look here. We have 2, 7, 22, 67, 202, 607. So I see a couple features here. One feature I see is even, odd, even, odd, even, odd. I could also say, look at our ones place. 2, 7, 2, 7, 2, 7. That's also another cool feature, is that our ones place value alternates, which means goes back and forth between 2s and 7s. So either of those features would work. Okay, ladies and gentlemen, again, I know there's a lot of side work for these problems, so it's going to take a lot of time. Push through and do the best you can. Have a great day.